Okay, this was the last page of the packet. The corresponding parts of congruent triangles are congruent. Called practice 4.4 here. Okay, so we wanted to use side, 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 side angle, side angle, side angle, or angle, angle, side. First, to show the triangles are congruent, and then we can use the corresponding parts of congruent triangles are congruent to prove what they're trying to tell us to be true. Okay, so for number one, we want to show that angle A is congruent to angle C. In order to do that, we first need to show that the triangles are congruent. Once the triangles are congruent, we know all three pairs of angles and all three pairs of corresponding sides are going to be congruent. Okay, so for this one, we have a right angle here. This means that BD is perpendicular to AC, which means this is also a right angle. If we go down our list, we have shared sides. So we can say that BD is congruent to BD by the reflexive property. So we can use reflexive. And then we have two pair of sides that are congruent and one pair of angles, and that pair of angles is included. It's between the two pair of sides. So we're going to use side, angle, side. Right, and that tells us our triangles are congruent. And since our triangles are congruent, we know that corresponding angles are congruent. So we know that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. Okay, second one. We want to prove that HE is congruent to FG. Okay, they're giving us two pair of angles that are congruent. If we go down the list, we don't have vertical, but we do have shared sides. So we fill in a hash mark here for our shared side. So HF is congruent to HF by the reflexive property. So we're using the reflexive property. Okay, we now have angle, side, angle. We have two pair of angles, one pair of sides. The pair of sides are included, meaning that they're between the two pair of angles. So we have angle, side, angle. We just go in order there. Once we have angle, side, angle, we know the triangles are congruent. And since the triangles are congruent, we know that HE is going to be congruent to FG because the corresponding parts of congruent triangles are congruent. For number three, the easiest way to do this is to use the third angle theorem. You have two pair of congruent angles, so we can use the third angle theorem to say that our third pair of angles, K and P, are congruent. Right? If you have two pair of congruent angles, then the third pair are congruent. That's what the third angle theorem tells us. But if we were to use the triangle postulate, we would have angle, side, angle. So that tells us the triangles are congruent. Since we know the triangles are congruent, we know all the pairs of angles and all the pair of sides are congruent. So we know that angle K would be congruent to angle P because the corresponding parts of congruent triangles are congruent. Number four. We can use the reflexive property here. Okay, and then we have angle, angle, side. So we use the reflexive. And then we use angle, angle, side. We have two pair of angles, one pair of sides. It's non-included. It's not between the two sides. And then since we have the triangles are congruent by angle, angle, side, we know that the corresponding parts of congruent triangles are congruent, which tells us angle Q ST is congruent to angle SQ. Once we know the triangles are congruent, we know the corresponding angles are congruent and the corresponding sides are congruent. Number five, we can use the reflexive property. We now have three pair of congruent sides, so we can use side, side, side to say that the two triangles are congruent. Since the triangles are congruent, we know the corresponding angles are going to be congruent, so we know angle U is congruent to angle W because the corresponding parts of congruent triangles are congruent. Okay, we have vertical. So we have angle, side, angle. So we use the vertical angle theorem to show that the vertical angles are congruent. That allows us to use angle, side, angle. The pair of sides is between the two angles. So it's angle, side, angle. It's the included side. now that we have triangles congruent by the angle side angle postulate, we know the corresponding parts of congruent triangles are congruent. Okay, so that's going to tell us ZA is congruent to AC. Corresponding parts of congruent triangles are going to be congruent. Okay, FG and DG. So to show those are congruent, we can use the reflexive property. That gives us side angle side. So we first use the reflexive to show that EG was congruent to EG. And then we can use side angle side. So we have two pair of sides, one pair of angles. The pair of angles is between the two sides. So side angle side. Once we know the triangles are congruent by side angle side, we know the corresponding parts of congruent triangles are congruent. So we know that FG is going to be congruent to DG. Right? Because for congruent triangles, we have three pair of congruent sides, three pair of congruent angles. So once we know the triangles are congruent, we know all that's going to be true. Here we have vertical. Okay, so this will be angle, angle, side. So we can use the vertical angle theorem. Then we can use angle, angle, side to show that the triangles are congruent. Once we know the triangles are congruent, we know the corresponding sides are going to be congruent. So we know by the corresponding parts of congruent triangles are congruent, we know that our two sides of the triangle are going to be congruent. Okay, here we have reflexive. And then we can use side, side, side. Right, that tells us the triangles are congruent. Once we know the triangles are congruent, we can use the corresponding parts of congruent triangles are congruent to show that angle N is congruent to angle Q. Okay, and then the last two here are the proofs. Not a lot of room. Let me see if I can't zoom in on the white space. So we have statements over here, reasons over here. First step of any proof is the given. We're given that BD is perpendicular to AB. Okay, and we know that BD is perpendicular to DE. Okay, and then we know that BC is congruent to CD. Okay. So first thing we have here are vertical angles. So first thing on the list is vertical angles. So here's our two vertical angles. We know vertical angles are congruent by the vertical angle theorem. The vertical angle theorem tells us all vertical angles are congruent. So angle ACB is congruent to angle ECD. Okay. Then we go down our list. We don't have shared sides. We don't have a midpoint. We don't have a bisector. We don't have parallel lines. We do have perpendicular lines, though. Perpendicular lines mean that we have right angles. So they already have it drawn in for us, but angle B and angle D are right angles. We know they're right angles because they're perpendicular. They formed by perpendicular lines, and we know that perpendicular lines are defined as two lines that intersect and form right angles. So that's the definition of perpendicular. Right. Our goal here is to prove that A and E are congruent, so we first need to show that the triangles are congruent. Okay, well, we don't have to. Right here, we have two pair of congruent. We can use the right angle theorem to show that angle B and angle D are congruent because we know right angles are congruent by the right angle theorem. Then we would have two pair of congruent angles, and we could use the third angle theorem to show that A is congruent to E, angle A and angle E. Or we could first show the triangles are congruent and then use corresponding parts of congruent triangles. So let's do it that second way. So we have right angles. We can now say that angle B is congruent to angle D. Okay, by the right angle theorem, like we said. Okay, right angles are congruent. Okay, so you could now use third angle theorem. That's the best way to do it. But I think the idea here is to show the triangles are congruent. So why would these triangles be congruent? Triangle ABC is congruent to triangle EDC. Okay, it's going to by angle, side, angle, angle, side, angle. Okay. And now that we know the triangles are congruent, we can use the corresponding parts of congruent triangles are congruent to say that angle A is congruent to angle. So we have vertical angles, we have perpendicular lines. If we have perpendicular lines, we know we have right angles. If we have right angles, we can use the right angle theorem to say that right angles are congruent. Okay, then you have angle side angle. And then since we have angle side angle, we know the triangles are congruent. And then we can use the corresponding parts of congruent triangles to say that our two other angles are congruent. Okay, and again, the other way is right here, you could have stopped, and step 5 could have been the third angle theorem, and that would have worked as well. Number 11, statements, reasons. Okay, first step in any proof is whatever is given. So what's given to us here is that Fj is congruent to GH, and angle JFH is congruent to angle GHF. We go down our list, we don't have vertical angles, but we do have a shared side. So we know that FH is congruent to FH. Okay, and that is the reflexive property. Okay. We then have side angle side. Will tell us our triangles are congruent. So triangle JFH is congruent to triangle GHF. Okay. Now that we know our triangles are congruent, we know our corresponding sides are congruent. So we know FG is going to be congruent to JH. And that is your corresponding parts of congruent triangles are congruent. Once we know the triangles are congruent, we can use CPCTC to say that any of the corresponding sides are congruent or any of the corresponding angles are congruent. Okay, and that's